Another day, another normal day. Blessy woke up with a loud noise that she eventually got used to. She got straight up to her bed and opened her window to see the train that serves as her alarm clock every morning. Blessy lives somewhere in the slums of Manila, particularly near the train rails. Every morning, she will wake up because of the noise that is produced by the train. Blessy is a senior high school student, taking up science, technology, engineering, and mathematics in a public school in Manila. Good morning, class. Last meeting, I asked you to read in advance about thermal linear expansion. Can anyone tell me what thermal linear expansion is? Yes, Blessy. From the word itself, thermal, linear, and expansion, it can already suggest what this topic is all about. It is the increase or change in linear dimension of a solid due to the change of temperature. Okay, very good, Blessy. You may take your seat. So thermal expansion is basically the spreading out of substances when they get heated. The atom gets excited as they gain heat energy and therefore move away from each other, expanding. When we say linear thermal expansion, it is the same concept, but the expansion makes the item longer. If we want to measure linear expansion, we measure the length by which something has expanded or retracted due to gaining or losing heat. For example, let's think about a thin metal rod that has gained a certain amount of energy. To calculate the change in length, we use the equation delta L is equals to alpha L delta T, where alpha L is the thermal expansion, L is the length, delta L is the change in length, and delta T is the change in temperature. We have an example here. A steel is 40 centimeters long at 20 degrees Celsius. The coefficient of linear expansion for steel is 12 times 10 raised to negative 6 degrees Celsius. The increase in length and the final length when it is at 70 degrees Celsius will be what is known as a change in temperature. 70 degrees Celsius minus 20 degrees Celsius is 50 degrees Celsius. The original length, which is 40 centimeters. The coefficient of linear expansion for steel, or the alpha, 12 times 10 raised to negative 6. What we want to know is the change in length, the delta L, and the final length. The solution is shown. For the change in length, or the delta L, substitute the values of the alpha, initial length, and the change in temperature. After substituting, multiply the values. Then you will end up with the change in length is equals to 0.024 centimeters. For the final length, substitute the values of the initial length and the change in length. After substituting, add both of the values and you will end up with 40.024 centimeters. Understood? That's all for now, class. Please prepare for a quiz next meeting. Thank you, and class dismissed. Blessy went her way home. As she approached home, she noticed that there is a commotion just meters away. She then makes her way to the commotion out of curiosity. She saw that the train got into an accident. Maybe the train got into an accident because of the gaps between the successive trails on a railway track. I don't think it is essential, said the woman. Blessy then realized the lesson that they tackled during their physics class earlier. Thermal linear expansion. Excuse me, ma'am. I don't think your speculation is right. Hmm? Can you please enlighten me? The gap left between railways is not a mistake, because the reason is that the rails expand during hot season and the gap is provided for this expansion. If there is no gap, the expansion will cause the rails to bend sideways, indicating that linear dimension of a solid will change and expand, and it will cause accidents. Is that so, Iha? The lady said. Yes, ma'am. I'm taking into consideration the weather is not that good this past few days. Maybe that is the reason why the train got into an accident. The railways is somewhat slippery. Both of them smiled and bid their goodbyes.